what we were doing. We went over the plus plus and minus minus operator. If you write plus plus and minus minus behind the variable, that means increment or decrement after using the current value in the current expression. We went over this, for example. I'm just quickly reviewing what we did. M equal to m times k, and then k equal to k plus 1. This means multiply the current value of k by m and put it back in m, then increment the k. That's exactly what this will do. So this statement is equivalent to that, those two statements. We did these examples. And yeah, this is the example we stopped at. This example was written earlier in the last section, where we wanted to find all the devices of a number and count them. So to count the devices, so what I'm doing is, the test num is my test number for divisor. So all the numbers starting at 2 all the way to 1 less than the given number should be tested to see if any one of them divide the number evenly. And if it divides evenly, then we need to count it. And if you want to print it, you can print it also right there. The devices can be printed. Here we only needed to count. Test number going from 2 to 1 less than num should be tested. All right, so we ask the user to enter the number and we read it into num. And then while test num is less than num, because all the test numbers under num should be tested. And we test it in this if statement. If num modulus test num equal to 0, wait, this is, sorry about this. I changed it to, let me reopen this. I think in the previous class, I changed that program and forgot to save it. So don't save. Yeah, this is the right version. Test num, while test num is less than num, I need to test that number. If test num, num modulus test num equal to 0 is true, then increment the counter. Whether that was true or not, test num should increase. So that's why test num equal to test num plus 1 is not inside the if, it's outside the if. And so I need brackets here because I have two statements in the loop. The if statement is one statement, and this is outside the if. Okay, so test number increases, and with the new test number, I have to check this. Test number less than num is true. And if it is still under num, then I have to test to see if it is a divisor. If it is divisor, then counter goes up, and the test number will go up regardless of whether the last number was a divisor or not. So that's how it goes. And so when this loop finishes, test num is less than num is not true. In other words, we have tested all the numbers smaller than num, and so the counter has the count of all the devices smaller than num. So we print that, and that's our result. Now, if I want to use plus plus operator, I can the program will reduce significantly, and that's what I wanted to show you. So the test num has to be tested here, and I'm testing it. Right after testing the test num to see if it's a divisor or not, I want to increment test number. So I can put the test num plus plus right here behind the test num plus plus. Then I can eliminate this because test number is incremented by 1 right after testing current test number right there. So this can go. And also I can change the count equal to count plus 1 to count plus plus. But the point is now I don't have two statements in the loop. I only have one if statement. So that means this curly bracket can be deleted, and this can be deleted, and that reduces the program significantly. So that's the idea. The plus plus operator does help reduce the size of the program, and also, you know, it's more elegant to write the program this way.
So what happens to test number test number equals test number plus one?
Instead of that, I have test num plus plus right here.
Oh, you have it there. Okay.
Okay,
So in
so
the future, will we lose points for not including that, or is it okay to still use count equals count plus one semicolon?
you can still write count equal to count plus 1, and
Okay, gotcha.
the count plus plus is a simplified
Yeah,
version.
no, it's just simpler, but in the future.
And also test num plus plus basically eliminates a new line, a line of code which said test num equal to test num plus 1. It eliminated that on entire line. So it simplifies matters, but you can write it either way. Okay, no penalty for writing it this way or the other way. It just improved. It just improves the program and reduces the size of it, and for most people, it also helps read better. But you can write it either way. So when the program is correctly written, there is, I mean, no penalty for writing using certain feature and not using another feature, anything like that, as long as it's right. But only if it is incorrect, you will lose points, or inefficient for any reason. You write things that are just making the system work unnecessarily, you will lose a small credit for that. Okay, so moving on to the factorial problem. Write a program to obtain a positive integer from the user and find the factorial of it. The factorial written as n factorial. This is the notation in math for factorial n. It means multiply all the numbers from 1 to all the way to the given number. The product will be the factorial. So we want to write a program that will find the factorial of any number given uh, by the user. So we're going to get a number from the user and find factorial of it. Let me clear the board. Okay, so I'm going to begin with main. And I need to find a factorial of any number entered by the user. So the user number, I will store it in the variable n, and I'll use a variable fact for storing the factorial. And it's going to be product of many numbers. So to calculate product of many numbers, you must start your variable at 1 and then multiply this variable by the new numbers. By repeatedly multiply this same variable by new number, put it back in the same variable. That's how you accumulate product of many things. So n will be the number given by the user, and I'll have to use another variable k for the multiplier. See, I'm doing this. If the user enters like, let's say 30 as the number, then I need to multiply 1 times, 2 times, 3 times, 4, all the way to 30. So to hold this product, I'm declaring that variable fact. The fact is going to be holding the product. Initially, I'm putting this one in it, And then I need to have another variable holding this number 2, and I'm going to use k. And then I will multiply fact, which has this number, by the k and put the result in fact. That way, fact will now have the product of these two. And then same fact should be multiplied by 3. So the k will change. Right after multiplying by k, the k will change by 1. So that's the idea. So that k will be here now. K was here. After multiplying by the k will change to 3. Then after multiplying the fact by k will change to 4, all the way to 30. So that's, I can do it in a while loop or a for loop. So I declare the k, this variable k up here. I only need to declare it. And then my for loop can say for k going from 2, that's what k is initially, 2, to k less than n. Oops, I don't have the value of n yet. I forgot to do that. Okay. I have to get the data from the user and forgot to write that. So C out, enter number, then C in n. So n has the number. After that, my for loop will begin for k going from 2. The fact is already 1. So fact has this very first one. I need to start k at 2. So k going from 2 to k less than n, and the n is the entered number by the user, incrementing k by 1. So k plus plus k. So when you write the for loop, the control variable k is what I'm using throughout the for loop. As you can see, k starts at 2, goes up to n, incremented by 1. For all those k's, I need to do fact. Fact currently has a 1. I multiply it by k and put the result back in fact. I had to put the result back in fact, only then I'm multiplying up. And right after doing this, the k will increase here. And then as long as k is less than n, the new k is multiplying the fact. So let me show you why this is going to work. Fact, I'm tracing fact and k. Initially fact is 1, k is 2. And then I got the n from the user. N is some large number, like let's say 10. Doesn't matter what that is. K starts at 2, and k less than 10 is true. So multiplying fact by k. Fact is 1, k is 2. 1 times 2 goes back in fact. So fact is now 2. And after that, k increases here. So k changes to 3. And now we are back to the top of the loop, checking this condition. K is 3 and it is less than 10. So therefore, I'm going to execute this again, which will multiply current value of fact by k. Current value of fact is 2. So 2 times 3 is 6. As you can see, now I have multiplied 1 times 2 times 3 already. And then the k plus plus is executed, changing k to 4. And with the 4, I check this condition, 4 less than 10 is true. So fact is multiplied by 4. So 6 times 4, 24 goes here. And then k plus plus will change the k to 5. You can see I have already multiplied 1 times, 2 times, 3 times 4 to get 24. Fact has 24. So it keeps going all the way. When k is actually k should be less than or equal to n in this condition. When k becomes equal to 10, you still have to multiply by k, the 10, last number 10. After that, k becomes 11 and the loop terminates because k is not under 10 anymore. So by that time, all the multiplications have been done. So that loop finds the factorial. this loop finds the factorial of the number given by the user. So after the loop ends, you need to see out facts. So that's how you multiply up many numbers. You have to use the same variable like fact here and multiply it by the new number, put it back in fact. That's the only way you can multiply up many numbers. All right, so let's go to the next one. This is the program. I'm using while loop here, but on the board I used a for loop. Doesn't matter, either way it's correct. All right, here is a warm-up exercise. Write a program to obtain an integer number from user and determine how many of these multiplications should be done to get the number over the given number. So now it's a slightly different question. You're multiplying these numbers 1, 2, 3, 4 until the product goes over the number given by the user. So it's kind of similar to the program I wrote on the board, but the limit is it's not the factorial. We're not just finding multiplication of all those numbers under the given number. We are multiplying all the numbers until it goes over the given number, until the product goes over the given number, and then count how many multiplications have to be done to do that. All right, so let me see if anybody can write that program.
Wait, does that say fact equals what?
In the program on the
Yeah,
board.
what does that say?
Uh,
No, no, at the bottom in the for statement.
the first statement, for k going from
No,
2,
no, no, fact.
fact equal to fact times k.
Okay, gotcha.
All right. And after the loop, I have C out fact. Sorry about my writing, my pencil doesn't always do a good job. So I'm waiting for you to write your program in the chat. Or if you want to handwrite it, then handwrite it and show it to me on the by putting it against the camera. No one has any solution? It's kind of similar to the one we just wrote, except that the condition will be changing. We need to keep doing the multiplication until the product goes over the given number. All right, no one presented a solution. So let me let me go ahead and do that. We need to get a number from the user and then perform this multiplication. So the user number, I'll store it in N, and this multiplication, I'll store it in prod. And so prod has to start at 1. And I need another variable to track the multiplier. Multiplier is going to be 2 initially, and then it'll change to 3, change to 4, and so on. So I'll call it k equal to 2. That's my multiplier. So far, that's all I see as needed. C out, ask the user to enter the number. And C in N. And then I need to keep multiplying the prod by k, as long as the product is under N. See, that's what the problem asks for. But it also asks you to count how many such multiplications are done. So I'm going to start a counter at 0 to count how many multiplications are done. All right, so now I can say the N has a value now. I got it from the user. And the prod is the control variable. Prod, because the problem says you need to do this multiplication until the product goes over the given number. So therefore, I need to say while the prod is under number N, I need to multiply prod by another k. So prod times k should go back in prod. Remember, both sides have to have the same variable. That's the only way to multiply up many things. K is right now 2. So prod was 1 and k is 2. And I have done one multiplication right now. So therefore, my counter should go up to 1. It was 0 before. And so if I put count plus plus next, that will increment the counter right after doing this product. So I multiply product by k and increment the counter to keep track of the count of the product multiplications. And then I need to change the k. So k was 2. And if this product is not, if the product is still under n, I need to multiply next k. So therefore, right after the prod equal to prod times k, if I put plus plus right here, that'll do it. That'll increment k after multiplying the current number. So prod was 1, k was 2, 1 times 2 is done. Immediately after that, k changes to 3, and counter increases to 1 now. And then you go to the top, prod less than n is true, prod is equal to 1, so prod less than, sorry, we did the multiplication. Let me start over. Prod is 1 and k is 2, count is 0. Prod is 1, k is 2, count is 0. And so let me erase this. Okay. Prod is 1, k is 2, count is 0. Okay, count is 0. And with that, prod less than n is true. So therefore, prod times k will be executed. So prod is multiplied by 2. So prod changes to 2. And right after that, k increments. So k changes to 3. And counter increases to 1. After that, you go back to the top, prod less than n is true, so prod is multiplied by k again. So 2 is multiplied by 3, so now it's 6. And then the k changes to 4, and counter increases to 2. And then you go back and check prod against n. Prod is still less than n. n is some large number given by the user, like 100. So as long as our product is under 100, we have to keep going. So now the prod is, now this will be executed, which means 6 will be multiplied by 4. 24 goes back in prod, 24. And 10K changes to 5, and counter goes up to 3. The counter is just counting how many multiplications have been done. So that 24 is now checked against 100, still true. So multiplying prod by K, 5 times 24, 120. So 120, and then 5 changes to 6, and 3 changes to 4. And then you go to the top, and now the prod is over 100. So therefore, loop terminates. When the loop terminates, our count has the answer. So see out the count. Count has the count of how many multiplications were done to get the number to go over 100. All right, let's now understand the plus operator in front of n, pre-increment or pre-decrement operators. So if you put the plus or minus in front of the n, that means increment or decrement before using in the current expression. So if you remember, if you put plus or minus behind it, it means increment after using in the current expression. So this means increment before. There is a difference. So let's look at a simple example. If I write so let's say a variable m has a 10 and k has 5. So if I now write m equal to m times plus k. Earlier we looked at having k plus plus. Now this one says plus k. Then after executing this, what would you have in m and what would you have in k? Anybody? No one has an answer for that? It's a very simple question, nothing difficult about this. M has a 10, k has a 5, and if I do m times plus k, what will that produce?
Wait, you said a what? Repeat that, please.
M has a 10, you can see the board, right? N has a k has a 5, and I'm writing m equal to m times plus k. Now I just went over the explanation of what happens if you have plus in front of the k instead of behind the k. If you have plus behind the k, it means use the current value of k and then increment. If you have plus in front of the k, it means increment first and then use.
Is it 60?
60, right? M will be 60 and k will be
86.
6, right? Yeah, okay. Now I'm a lot happier to see someone answer that question. Incrementing first. So that means k will be incremented to 6, and the 6 will be multiplying the 10. And so you'll get 60 now. That's the difference. Okay, so let's look at the next page. Now that will be true even if I use cout statement. So let me say this. All right, forget these now. Let's say M has a 10. And if I say C out M plus plus, that means C out what? What will be printed here? It means, remember, always plus plus will be done after executing the current statement. So that means this will print the 10 and then M will change to 11. That's what happens here. It'll print the 10 and then M will change to 11. So if I do a C out M afterwards, that'll print what?
11.
Print what again?
11.
11, yeah. So therefore, these two statements will print 10 and 11. So with that understanding, let me see if you can figure out the output of these statements. Num is 2, and then C out plus plus num, ENDL, C out num plus plus, C out num. So there will be 3 numbers appearing one below the other. And I want to see if you can tell me what those numbers are.
Professor, is it 334?
Okay, I have one answer, 334. Any other?
I agree.
You have the same, okay.
Yes.
Same, okay, very good. That is correct. 334 is correct. The first C out will increment the 2 to 3 and print, so that's 3. The second C out will print the current value, which is 3, and then increment to 4. So the third one will print 4. So 334 is correct. Going on to warm-up exercise. So let me see if you can figure out the output. There will be 3 numbers printed. You need to tell me what they are.
Is the answer is 1354?
1354 are correct. Very good. Everybody see that, or anybody needs explanation?
Can you explain that?
Yeah, can you explain that, please?
Okay. In this product, 2 times minus minus k, the k will be reduced first, and then multiplication will be done. So that'll be 2 times 5, which is 10. And then 3 will be added to it. After adding 3, n will change to 4. So therefore, 2 times 10 plus 3, 13. So therefore, m is 13.
Isn't wait, I'm confused. Don't you do when you do n plus plus, doesn't that become 4?
After using 3 in this expression.
Oh, okay.
Okay. So that'll be 10 plus 3, 13, and n changes to 4 afterwards. So m will be 13, n will be 4, and the k here changed to 5 from 6. So k is 5. So 13, 5, and 4. Okay, going on to the warm-up exercise. We don't need that. We don't need that warm-up exercise. All right, so order of precedence. We have new operators, plus, plus, and minus, minus. So we need to understand order again. Well, the plus, plus, and minus, minus will be done before any of the arithmetic operators. Well, that's already clear from what we understood about these operators. Let me explain. If I write something like m equal to m times k plus plus, or m equal to m times plus plus k, the plus plus is So in this case, clearly k will be incremented before multiplication. But that's the meaning of that. Increment k first and then multiply. Here, k plus plus will be carried out after using current value, but I mean, according to the order of precedence, the plus plus will be carried out first, which basically means still the meaning we have learned is the correct meaning. The multiplication will be done, and this k plus plus means increment k afterwards. So it'll do that, just that. So this order of precedence, it doesn't matter. I mean, you understand what that plus plus minus minus will, how that will be handled. And that's all that matters. Okay, moving on. So these plus plus and minus minuses, programmers sometimes, go crazy with that idea and write the plus plus and minus minus very in a complicated manner. So let me, on the board, I'm explaining something. If I write k minus minus and then another minus minus, semicolon, will the system understand that? Will the compiler understand that? Yes, it will, because it means reduce by 2, reduce k by 2. But it would be better if you just write a parentheses, but it's not necessary. This will be understood. Whenever it can be understood, it would accept it. Compiler will accept it. It will not accept it if it cannot be understood, like this. If it doesn't have a clear meaning, like this, for example, k minus minus, and then what you want to say is j with the minus minus in front should subtract. So you wrote k minus minus, another minus, and then minus minus j. But now it has no unique meaning, because it could be interpreted as k minus minus, another minus minus, and then subtract j. It could be understood this way. So there are more than one meaning. It could be also understood as k minus minus and subtract minus minus j. So when there is multiple meaning, the system will reject it. So let's look at some examples. This will be acceptable. It'll work. It'll be incrementing k after using current k and subtracting j. So you can understand that. So that'll work. If you have parentheses, then there'll be no problem. It'll accept that. This will not be accepted. It has more than one meaning. The minus minus can go either way, with j or with k. Like I explained on the board. If you put parentheses like this, then it'll be accepted. And this will be fine. It has clear meaning. So if the meaning is clear, it'll be accepted. Otherwise, error message will be produced by the compiler. Okay, so can somebody tell me the value? Let's do just first one, j plus plus minus k. What are the values? What is the value of this expression and the value of j and k afterwards? Value of the expression first, and the value of j afterwards, value of k afterwards.
Is it -5?
Okay, I have one answer, -5 for the expression. Anyone else?
It's a -6.
-6 is right, because this subtraction will be done as 3 minus 9. J will increase only after using current value, right? Everybody see me? So 3 minus 9 will be -6, and j will become 4 afterwards. K will stay at 9. Okay. I'm moving on. So that finishes this section, and I need to do part of the next one also. So let's do that. Okay, here we understand we are going to learn how to find sums and products. We just did a couple of problems of that kind, but we need to understand how to do problems like that, even harder problems of accumulating sums and products. To accumulate sum of many things, you need to do this. Create a variable called sum, start at 0, and add the first number to it and put it back in sum, and then repeat this statement over and over. The new number will be added to sum and it will put it back in sum. Then the new number will be added to sum, put it back in sum. You have to keep the same variable sum on both sides. That's the only way to accumulate sum of many things. And if you're multiplying, then same thing. Prod equal to prod times number should be executed over and over with the number changing to the new number. So I'm going to do some examples. So let's see the first example. Write a program to multiply or add up all the odd integers from 1 to 30. We're going to add up all the odd numbers from 1 to 30. And so to add up, you have to use a variable called sum. Use a variable called sum and repeatedly add to the sum, put it back in sum. That's the right way. That's the only way. So 1 through 30 odd numbers will be 1, 3, 5, 7. I need to add up all those up to 30. 30 is not odd, so it will be 29 will be the last number we add. So to add up all those, I need to declare they're all integers. So int sum should always set to 0 before starting to add up. You need to have a variable holding these numbers. So I'm going to start a k at 1. So comma k equal to 1. And then the loop control is going to be k has to go up to 30 or less than 30. So I can say while k less than 30, sum equal to sum plus k. You have to add k to sum. The current value of k is 1. So I'm adding 1 to sum and putting back in sum. After that, k should change to next one. So I can put k plus plus right there. Not k plus plus, sorry. Because k is changing by 2. So if it's changing by 2, it's better to write that separately. K equal to k plus 2. Even though you can write k plus 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 plus, you can write that. I don't like to write the plus plus multiple times. It can confuse a reader. So write it this way, then see what happens. The sum was originally 0, and then I added the 1 to sum and put it back in sum so that sum changes to 1, and then k changes to 3 here, and then k is less than 30, so 3 is added to sum, put it back in sum, so k is now 4. See, that's a sum of 1 and 3 already. And then k changes to 5 here, k changes to 5, and 5 less than 30 is true, so 5 is added to sum, so now it's 9. So I have added 1, 3, 5 already. So it keeps going all the way to k equal to 29. When k is 29, I'm adding that, and the k becomes 31, and loop terminates. So I end up adding all of those odd numbers. If I'm multiplying them instead of adding up, then this line will change to prod equal to prod times k. That's the only difference. You're multiplying by k, and then k changes by 1, by 2. This will go in place of that. So you had to use the same variable on the left and right. Prod equal to prod times k, like sum equal to sum plus k. That's the only way to accumulate. So let me ask you a question. Suppose that I'm doing the same thing, except I'm not adding odd numbers. I'm going to add reciprocals of odd numbers, just reciprocals. Okay, then what change do I have to make in the program? Instead of adding k, what do I write here? if I want to add reciprocals of k, reciprocals of the odd numbers. The odd numbers are right here, 1, 3, 5, 7. But what I need to add up are 1 over 1 plus 1 over 3 plus 1 over 5. That's what I need to do, all the way to 1 over 29. So what change do I make in the program?
1 over k.
1 over k, that's right. I had to write it as 1 point over k because both are integers. So other than that, that is the correct way. 1 over k will mean reciprocal of that number. Suppose that I want to add up reciprocal of the squares. Then all I need is 1 over k times k in parentheses. So now I'm adding all the squares of the reciprocals of odd numbers. So it's just a minor change. The problem can be complicated, but the program doesn't change much. If I want to add up this series, let me see, let me clear this up here. 1 plus if I want to add up 1 plus 1 over 5 plus 1 over 5 squared plus all the way to 1 over, let's say, 5 to the power of some number. 5 to the power 10. Something like that. Let me change that question. I want to determine how many of these numbers should be added up. This series should be added up for the sum to go over 2. Sum to go over 2. How do I find the answer? I need to count how many of these are getting added up. So I need a counter and I need a sum. Sum will start at 0. Actually, I can start the sum at 1 to have this number in the sum. And then the denominator number starts at 5 and it has to change to 5 squared, 5 cubed, and so on. I can have a variable called denominator equal to 5. And then I can say while sum is under 2, because the problem says how many of these should be added up for the sum to go over 2. So int sum equal to 1. I also need a counter, count equal to 0. And then while sum is under 2, sum equal to sum plus 1 over denominator, 1 point over denominator. And then the denominator needs to change. Denominator should be multiplied by another 5 to get the next denominator. So denominator equal to denominator times 5. That'll go to the next denominator. If I put these two in the loop, I need to increment the counter to see, because I need to calculate how many of those have to be added up. And close the bracket. This will find the count. Find the count of how many of those should be added up. When the loop finishes, see out, count, and you have the answer. All right, we are out of time now, so I'm going to stop here.